Morning, everyone. My name is Paul Gabriel. I am the Geoscience Data and Software Services Manager here at Segal, UK. Welcome to today's webinar. It's entitled Benchmarking Subsurface Compute with Blueback System Centre, BSC for short. How does it really perform? Oh, not that. Next slide. I don't want to end the... So, thank you for signing up to this webinar. We've been running quite a few of these. This is our second round of doing this. Please do tell us what more you'd like to see. We can keep going and keep adding more. Contact your Segal account manager or email sales@segal.com for any input you'd like into what we do next. So the format of these sessions, relatively straightforward, 20 to 30 minutes coffee break type session. We're recording this live right now. You're going to get an email copy of the recording 24 hours after this. We're also going to upload it onto the Segal YouTube channel. If we've got any time at the end, we can do a little bit of a QA session and you can submit your questions in the GoToWebinar chat console. So, what's the story today? Our computers are aging. Do we need to upgrade? So, in my novel example, I have an old laptop running Petrel, and I have a new laptop running Petrel. Our supplier has this new model to offer us. What I'd like to know is it more performant at running Petrel? And if yes, how so? The way we can begin to answer this question is to use System Centre, BSC, to run different Petrel benchmarking tests on these two machines to generate real-world Petrel performance data, which we can then compare. So what I'm going to show you after the next slide is an introduction to BSC, to System Centre. I'm going to run through some of these different types of performance benchmarking tests, the first of which is known as these canned workflows. I'll explain what they are. And we can also run some performance workflows in Petrel workflows themselves, and I'll show you what that looks like, and I'll show you how that could run in your environments. So just a quick overview of the tool itself, just in PowerPoint. System Centre is a lightweight Petrel plugin that you'd install on your Petrel workstation. And what it does, as Petrel fires up, we're pushing some real-time information about the Petrel environment, the performance, the users, usage, license to a SQL database. So we're capturing user behavior. So in terms of Petrel sessions, how long are sessions overlapping, when the sessions are taking place, what projects the users are using, any exceptions that are occurring inside of Petrel. We're capturing those. We're capturing license information. So we're looking specifically at what licenses are checked out, what modules are checked out, including plugins. We are looking at an overview of the Petrel configuration across your environment. We're looking at the variables that have been set up between the different Petrel instances. And we're looking finally at this workstation performance. The way we're doing that is by capturing Windows performance counters as part of these Petrel runs. And the specific topic of today's talk is looking really at this performance data that we're capturing. The idea here is that as you're capturing all this information from all these different machines, you can implement operational efficiencies, whether that's with licenses or specifically in this case, workstations, performance, right sizing your environment. You can look at the data in the System Centre viewer, which I'll show you first, or you can take the data from the SQL database and ingest it into your to any BI tool or Excel, and I'll show you an example of that too. So just before I go any further, our focus today is really about generating performance counters, Windows performance counters, and we can generate these in 3 different ways with System Center. The first one is session profiler sampling. So what that is doing, as a user runs the Petrel executable, the session profiler sampling will be capturing the Windows performance counters during that session and sending them to the SQL database, which we can then review and begin to analyze. So you can begin to analyze users' performance of their Petrel workstation against one another. What we're really interested in today is benchmarking workflows. So the 2 of those that we can run are Petrel workflows. So these are internal Petrel workflows themselves, and I'll show you what that looks like and how that could work for you. And Segal canned workflows. I'll explain a little bit about what those canned workflows are. The idea here is we are able to run Petrel workflows and Segal workflows again and again on different machines, generating a known quantity of Windows performance counters that we can then analyze. And you can run these operations across many machines across an environment to generate this benchmarking data and then compare it. So we're going to jump into a live demo. So first of all, I'm going to show you the System Center viewer. So what we have here, I'm not going to go into too much detail, but just give you a light overview of exactly the type of data we can capture. So this is the System Center viewer. This is pulling data directly from the SQL database that I have running. This is an example database of some internal users. I have 2 instances of Petrel running on 2 different machines. I have one running on this machine as it is. You can see that that project is open, and I am one of the 2 users that's running Petrel. We have information about license usage, the number of sessions per week, the number of lost sessions per week, a lost session being one where license was lost or Petrel crashed, number of exceptions that have taken place per week, number of users that have used Petrel per week, and the fastest startup times by Petrel version. So all this data is currently stored and sat inside an SQL database. You can pull this into your own analysis and do your own reporting, own monitoring, own alerting on all of this data. The System Center viewer is just a simple tabular interface to give you an overview of the data that we're capturing. So in terms of license information, we're capturing user, the license, the machine, start time, end time, duration of the license take, the version, what the current status is. At the moment, I am running Petrel and I'm executing some of this. We could crop this down. I don't want to focus too much on license usage, simply just giving you an overview of we are capturing plugin license information and we're capturing the other modules that exist inside Petrel too. We capture what Petrel projects the users are using, and you can see where those projects are. So this is useful for a data manager. Sometimes if a user is storing a project on the local drive, project tracker, can't see that, for example. And here you have an overview of all the different paths for the projects. We capture some machine information, so some high-level stats on the machine itself, which we can then interrogate later on and compare and use it to compare with our benchmarking results. We have a result list of the different Petrel installs available, what Petrel plugins are installed. We have lots, a lot of Blueback ones, and we also list the different versions of the Blueback. The different versions of the plugins themselves, allowing you to do a quick cross-check to see if everyone is on the same version of a particular plugin, for example. We capture Petrel settings. This is taken from the system settings themselves. In our case here internally, we aren't very good at using global setting files. In many corporate environments, you guys will be pushing these files configuring Petrel with some set standards, such as ZGY file location or potentially the seismic file cache. But the idea is we're capturing lots of different stuff that you can interrogate later on. And then finally, I just wanted to mention that we're capturing this exceptions information. Again, you can take this data out and perform further analysis by breaking these down and reviewing those and beginning to understand trends in the exceptions. But from our purposes today, we want to look at performance benchmarking. And I mentioned there's two different methods that we're going to look at, the canned workflows and the Petrel workflows. So first of all, we're going to start with the canned workflows, and I'll explain a little bit about what they are and show you how they work. So jumping to Petrel, this instance of Petrel has the System Centre plugin installed. And if I put it into the data management perspective and click the monitoring and reporting, you can see that I have this Blueback System Centre. This Blueback System Centre there's three buttons from this Blueback System Centre plugin. What we're basically doing with the canned workflows is we're running repeatable tests, and there's two specific tests. There's a load and a realize. And the load is taking a seismic file from a location, and depending on what you'd like to test, that location could be on a network or it could be on a local drive. In this case, the testing I've done is been running the load from a local drive location, testing the disk itself. But you could, if you wanted to test your network, you could run it from a network. All the load is doing is it's taking this seismic file, this ZGY file, taking it from disk and loading it into memory, into RAM. And what we're doing as that process is running, we're looking at how long it takes, and we're capturing Windows performance counters as that operation is taking place. We can also do a realize canned workflow routine. And what that is doing is that is taking the file from its location here, putting it into memory, and then writing it back out. And you can specify, depending on what you're looking for, the location of where you write that to, whether that is a local disk that you want to test or whether that is a network disk that you want to test the speed of. And the idea here is that you can run these locally like this by just simply clicking it here inside Petrel. You could also run them from a batch file from command prompt, and that looks a bit like this. So this is the syntax that you'd be using. So you can run this locally from a batch file. You could PowerShell it up and run it across a group of machines. And you could run this again and again and again and generate some data. And so that's what I've done. I've gone in and I've run the profiler to run load and realize operations for both the old machine that I have and the new machine that I've been provided by this vendor. So what we're going to do is we're just going to have a look and see what that data looks like. And I jump back into the System Center viewer and I toggle on this profiler tab. Inside this profiler tab, I'm now seeing all the different performance benchmarking summary information that I've run. And you can see that I've run lots of these load and realize jobs. So if I toggle on, for example, just looking at the load process for an 8 GB volume. So the load is taking it from my local disk on these two machines and putting it into memory. And what you have here at the bottom in these two graphs is duration. So on the left-hand side, you have the new machine, and on the right-hand side, you have the old machine. So what we're saying here is the longer the duration, the worse, the slower that machine. And we can begin to, if we wanted to, we can look at an amalgamated view of all of these operations. And an example of that would be to take this information into Power BI. What I have here, really simple stuff. It's the same data, but just showing you how you can take this stuff into Power BI or into another BI tool. Here at the top, I have load operations. Green is new machine, orange is old machine. And what you're seeing here is that for the load processes, it appears that for the larger volumes, the new machine is running a little bit faster on average than the old machine. If we look at the realize jobs, which is taking it from disk to memory back to disk, you can see that on average, the new machine is running faster than the old machine. So the green average durations, it is running it slightly quicker. We can, if we want to, delve a bit deeper into these numbers. This is simply duration. If we want to, we can break down and investigate specific Windows performance counters around these operations. And an example of that is looking at these realized operations and breaking that down a bit further. This is super simple analysis, but it's giving you an idea of what's possible here with all these Windows performance counters. So what we're doing now is we're simply looking at the two different metrics, well, three different metrics, but for two different components, the hard drive and the CPU. On the left-hand side here, what we're saying is for the realize operation, which is taking it from disk to memory back to disk, the old machine, which is the orange, each transfer is taking a slightly longer on average period of time for the old machine in comparison to the new machine. One of the reasons for this is that the new machine has a faster SSD drive than the old machine. And we'll see this type of, same pattern of behavior when we look at the Petrel workflows. In terms of CPU, what we have here is just a simple breakdown of the average CPU total, which in this case is the primary indicator of the processor for the Petrel process itself. And what you can see here is that the green, which is the new machine, the processor is running faster for the Petrel process than the old machine, which could indicate why it's able to run some of these operations a bit quicker. This value is derived from the fact that the new machine has a greater number of cores than the older machine. The chipset is slightly different. So that's a really simple, quick overview of this canned workflow methodology. So we run these canned workflows. You can run them across an environment. You could run them again and again, and you could do that through PowerShell as a batch script and analyze the data and give you quick results. The comment might come back, which is a 32 gigabyte volume isn't really real world. I want to push my machine much harder and replicate real world G&G workflows. So the second thing I'd like to show you is how we can run these Petrel workflows with the capturing of the Windows performance counters. So if I jump into Petrel, I'd like to show you what that looks like. So I have my Petrel workflows pane here in the bottom left-hand corner. And in this example, I have some workflows, some example workflows. The idea here is that these workflows are pushing the machine in different ways. The Wells benchmark is a test which is displaying, test the display and operation of well data. The geophysics is testing the display and operation of seismic cubes. So we're able to push and pull much bigger files, whereas the Wells benchmarking is small files. And then the model building is a real world modeling procedure, which is building grids at different resolutions. So we're pushing and pulling different things. The way this is working from a system center perspective is that we have a particular patrol workflow. The take-home message here is that this can be any patrol workflow and it can be any data. And the idea here is that you're able, using System Center, to begin and end the profiling, which is what this start and stop profiler at the end of the workflow show. What this is saying is, start this workflow, start the profiler. The profiler, when toggled on with profiler sampling, will begin to measure and capture the Windows performance counters as the Patrol workstation is running through this workflow. And what we're then able to do is, if we run these workflows again and again and on different machines, as I have done, you can then begin to compare the performance of these machines against each other using real world exercises and real world data. You can see too that there are these tag events. These are simply markers that we're putting into the sampling data at regular intervals as part of the process itself, which allows us later on to begin to see exactly what the machine was doing at any point as part of that workflow. So in other words, by tagging this geometrical modeling event here using this tag event in the workflow editor, we're able to see, as soon as the machine begins the geometrical modeling process, we can begin to see what the Windows performance counters are doing on that machine, and I'll show you what that looks like. So the idea here is that you can run any workflow that you have and begin to run this. You could run it locally like this. Again, you can run these workflows from command prompt. You can run them as a batch file from PowerShell. And you could do this across an organization. So long as you have the data in the right place, it's possible to push this through and run it over a weekend every month, for example, to begin to check that the performance of your workstations aren't degrading, for example. So what I've gone and done, I have run these workflows on the two different machines, the old and the new. And what we're going to do first is just have a quick summary overview of how the two machines compare when running these. And I'm firstly going to do that in Power BI. Super simple analysis here. All we're doing is looking at the average duration for the running of these workflows. So I ran each one 3 to 5 times. And you can see the green is the new machine, the orange is the old machine. And you can see clearly that the new machine, with its slightly improved chipset with more cores, slightly faster, newer SSD technology, is able to run these 3 workflows faster. If we delve into the Windows performance counters a little bit further, what we're able to do here is actually just do some really simple summary stats on these different workflows and begin to see some CPU, memory, network, and disk information against each other. So if I just have a look at the wells, for example, start with wells, what we're saying here is we're beginning to see how the Windows performance counters that we're capturing differ. And this is just a simple overview, and I'm going to show you a little bit more detail in the System Center viewer. But what we're seeing here in the top left-hand corner is CPU activity, specifically around the Patrol process. The right-hand side, the average total amount of memory consumed by the Patrol process, the average network interface, bytes total per second, and then the bottom right-hand corner is the average transfer speed per second of each transfer. And so if we look at the different workflows, so the Wells workflow, the telling thing is here in the bottom right-hand corner, where we're seeing that the transfer speed for the individual transfers for the old machine, the orange, are slower than the new machine, this green column. And that harks back to what I showed you earlier with the canned workflows, that it looked like one of the limiting factors could be the speed of disk. We're pushing and pulling a lot of small files as part of this Wells workflow, and that could be a contributing factor to the reason why it takes longer duration. If I jump to the geophysics, same type of thing. We're breaking down the individual Windows performance counters for the different components. Here, it's interesting to note that the CPU, again, as part of the patrol process, is being pushed harder because of the greater number of cores for the new machine in comparison to the old machine. And if we finally look at the model building workflow, we can see again in the bottom right-hand corner, it looks like there's a large discrepancy in terms of the transfer speed between the old machine and the new machine. So each transfer is taking much longer period of time. And that's important. The gridding workflow that we're using is pushing and pulling lots of small files back and forth to the disk. Again, indicating that it could be that the disk is the contributing factor to the increase in speed by the new workstation, the new laptop. So finally, I'm just going to delve into System Center Viewer and show you how we can see the individual Windows performance counters running over time. To do that, I jump into Profiler Samples, and I'm just going to show you two examples. I'm going to put it onto the geophysics, and I'm going to crop it to an individual run. So this one, and I'm going to look at the CPU. So what you're seeing here in the pink is the CPU total. So this is just for the patrol process of the pink is my old machine, my existing machine, and the blue is the new machine. And what we're seeing here is the geophysics patrol workflow tagged with these indicators here, showing us what the patrol workstation, the machine, how it behaves as soon as a particular process is run within that workflow. So if I look, for example, here, the volume attribute, structural smoothing and realization on the 10 gig volume, CPU drops and all of a sudden spikes and hits its limit. And you can see that it sits at that limit for a period of time. Whereas on the new machine, again, we see the same process. CPU drops, spikes up, and hits its threshold at 300% CPU total. The CPU total duration is shorter for the new machine than it is for the old machine, possibly caused by the fact that it's running faster than the old machine. So by using these workflows, we're able to capture real-world patrol data, and we're able to analyze the Windows performance counters during these operations, these benchmarking workflows, and we're able to see at specific points of the operation what patrol is doing, and we can couple that to the process and begin to analyze that information. So the take-home message here is you can use any workflow. It could be these example workflows, it could be any workflow, but you can couple these tags to the capture of the Windows performance counters and do this analysis. So that's what I wanted to show you today. Thank you for watching. We'd love your feedback. Let us know what more you'd like to see. Please get in contact to support.geo@segal.com if you have any questions. Next Wednesday, we have another webinar. What does Blueback Odyssey really tell me? How to use the post-inversion QC tools. It is 11 o'clock. We've run out of time, but if you do have any questions, please just email them to support.geo@segal.com and we will get back to you. Thank you very much for your time.